Hi, this presentation is based on data from nuclearpower.com, which is a powerful source of information on physics and energy. In this presentation, we will explain some basic energy consumption facts. You will learn how much we depend on energy and what is the world's energy consumption. You will also find out how much energy you use to heat your house and how much to drive your car. Let's start with the definition of energy. Energy is the potential to do work or to produce heat. You must have some energy to accomplish work. It is like currency for performing work. You must expend at least 1 kilojoule of energy to do 1 kilojoule of work. For better understanding, let's take 1 joule. 1 joule in everyday life corresponds to approximately the energy required to lift a medium-sized apple 1 meter vertically from the surface of the Earth. It is the kinetic energy of an object with a mass of 1 kilogram moving at 1.4 meters per second. It is the heat required to raise the temperature of 1 gram of water by 0.24 degrees Celsius. It is the amount of electricity required to light a 1 watt LED lamp for 1 second. 1 joule is released by approximately 31 billion fissions in a nuclear reactor. That is 1 joule. Energy is usually not given in joules but in multiples of watt-hours. 1 kilowatt-hour is equal to 3.6 million joules. Kilowatt-hours are based on SI units. In the United States, the British thermal unit is the most common unit for comparing energy sources or fuels. Conversion between these two units is simple. 1 kilowatt-hour is equal to 3,412 BTUs. Energy is essential for most activities of modern society. Access to abundant, affordable, secure, safe, and clean energy is beneficial for humans. We use energy in the form of firewood, fossil fuels, and electricity to make life comfortable and convenient. Every product you have at home is most likely made of materials, which were obtained from Earth using a lot of energy. At home, we use electricity for our lights and fans, water heaters and room heaters, ovens, microwaves, and washing machines. We use petrol, diesel, CNG for our cars, trucks, and buses. A large amount of energy is consumed in agriculture and industry. Humanity consumes enormous amounts of energy. And this amount is constantly growing. In order to understand the broader context, it is necessary to consider how much energy we use. Global direct primary energy consumption in 2020 was about 160,000 terawatt-hours. That's a really huge amount of energy. To illustrate, we'll convert the whole thing to coal. Assuming that the calorific value of hard coal is 24 gigajoules per metric ton, then we are talking about the equivalent of 24 billion metric tons of coal. That's about 20 billion cubic meters. This is equivalent to 300 million wagons of coal. Just imagine it. Back to the chart. Please note that the world's main primary energy sources consist of oil, 34%, coal, 27%, and natural gas, 24%, amounting to an 85% share for fossil fuels in primary energy consumption in the world. Energy consumption is constantly increasing. The share of individual energy sources also does not change significantly. We are totally dependent on fossil fuels, despite all efforts to decarbonize the economy. Oil, coal, and natural gas. Please do not forget that this energy gives us sustenance, products, warmth, and life in general. So it is not fair to just blame fossil sources. We all have to start with ourselves first. Where does this energy come from? Access to relatively cheap energy has become essential to the functioning of modern economies. However, the uneven distribution of energy supplies among countries has led to significant vulnerabilities. Oil and natural gas are energy sources that are distributed very unevenly in the world. International energy relations have contributed to the globalization of the world, leading to energy security and energy vulnerability at the same time. If we look at the map of countries with proven oil reserves, it is clear that some parts of the world, such as Europe, are highly vulnerable in this regard. The map shows proven oil reserves. For example, the European Union and China are among the largest importers of energy in the world. In the case of natural gas, the map is different, but the distribution of natural gas reserves in the world is very similar. How about coal? The distribution of coal in the world is different. More than 90% of the world's proven coal reserves are concentrated in only 10 countries. The United States tops the list, with more than 1/5 of total proven coal reserves, while China ranks 4th as the largest producer and user of coal. But where is this energy consumed? Primary energy sources are not only consumed in power plants. Industry, transportation, and the residential sector consume even more primary resources than electricity generation. Electricity generation consumes around 1/3 of primary energy. Most efforts are being made to decarbonize this sector. Despite this, we are still very far from decarbonization. Only a few countries, such as France, Sweden, and Norway, managed to achieve significant decarbonization of the electricity sector. The transportation sector accounted for 30% of energy consumption in 2020. Most energy used for transportation comes from crude oil. Recently, there has been a lot of thought about electric vehicles. However, generating the electricity used to charge electric vehicles is associated with fossil fuel consumption. The amount varies widely based on how local power is generated. Residential, commercial, and industrial sectors account for the last third of primary energy. Natural gas, used especially for space heating, dominates this sector. The problem is that most of this energy is consumed in large amounts during few winter months. On this slide, you can see the data of the U.S. Energy Information Administration. You can see the energy consumption by source and sector in 2020. An excellent representation of the relationship between primary energies and end-use sectors. The transportation sector consumes primary energy evenly throughout the year. There are periods when traffic is more or less intense, but the differences are not essential. We must add that transportation requires a lot of energy. For a better understanding, let's consider a small family car with a full fuel tank. Let's say 50 liters of gasoline. Such a car can travel, for example, 800 kilometers. The energy equivalent of 50 liters of gasoline is about 1.6 gigajoules of thermal energy. This equals 444 kilowatt-hours of energy. Or in the US units, the energy equivalent of 13 gallons of gasoline is around 1.5 million BTUs of energy. Please note that a typical gasoline automotive engine operates at around 25% of thermal efficiency. About 75% is rejected as waste heat without being converted into useful work, which means work delivered to wheels. This inefficiency is caused predominantly by the second law of thermodynamics. For industrial, commercial, and residential sectors, the consumption of energies is not so evenly distributed throughout the year. It's no secret that we use more energy throughout winter to keep our homes warmer and to light up the longer, darker hours of the day. For example, a small residential home consumes about 3,000 kilowatt-hours of electricity annually and about 15,000 kilowatt-hours of natural gas. Most of this energy is for space heating and air conditioning. These seasonal and energy-intensive uses vary significantly by geographic location, home size, and the fuel used. This picture shows a house with a 3 kilowatt peak photovoltaic system. Problem is that the highest energy consumption is in autumn and winter, when there is little wind inland and little sunday. In winter, daily energy consumption significantly exceeds daily consumption in summer or spring. Around 8 kilowatt-hours a day of electric energy and around 80 kilowatt-hours a day of thermal energy. Therefore, we must somehow store such amount of energy. Nowadays, energy storage seems simple. For example, many companies offer photovoltaic systems along with battery storage. Energy storage to cover daily production has an expensive but easy solution. However, as you can see, the problem is energy storage to cover the whole year and seasons. Around 80 kilowatt hours per one winter day cannot be stored in batteries. That's the real challenge. How do we store such an amount of energy today? The answer is simple. Fossil fuels such as coal, natural gas, and oil serve as energy storage. Fossil fuels store ancient energy derived from sunlight by dead organisms. These organisms died, became buried, and were then converted into these fuels. The energy of fossil fuels can be stored simply in gas, oil, and coal storage in large quantities. On this chart, you can see energy consumption per capita for different world regions. The consumption of each of us is in the order of tens of megawatt hours per year. To give an idea of how much it is, 40,000 kilowatt hours is equivalent to around 7 metric tons of hard coal. As you can see, we are totally dependent on fossil fuels. Despite huge efforts to decarbonize the economy, fossil energy consumption continues to grow. The future low-carbon mix must be based on a big share of renewables and a big share of baseload energy sources such as nuclear. This combination is the best energy mix that is low-carbon, reliable, and at the lowest cost. Without baseload energy sources, demands on the overcapacity of renewables, transmission system, and energy storage systems would result in excessive use of land and resources. We hope you have gained an insight into energy consumption. If you want to know more, visit nuclearpower.com, and don't forget to subscribe.